Okay, as we wrap up our unit on systems, that concept's not going to go away, but we're going to transition for a little bit into a geometry unit. So in order to be able to do what we're going to do next week, we need to understand characteristics of quadrilaterals. So what is a quadrilateral? A quadrilateral is a polygon with 4 sides and 4 angles. So any enclosed figure with 4 sides and 4 angles is called a quadrilateral. So if you see the quadrilateral to the left of your paper, the sides are ZY, YX, XW, and WZ. The angles are angle Z, angle Y, angle X, and angle W. Now, the sum of the measures of the 4 angles will always be 360. So remember, in a triangle, it was 180. A quadrilateral is 360. Now, what we also have to keep in mind with a quadrilateral is there's specific types of quadrilaterals, and we're going to get into that later in this video. But for now, let's focus on their angles. The sum of the 4 angles, so we could say angle Z plus angle Y plus angle X plus angle W is 360. So let's go find missing angles in a quadrilateral. We know that if I added all my angles up, it should equal 360. So if I'm going to combine my like terms of 95, 72, and 137, I get 304. Okay? 304 plus x equals 360. I'm solving for x, meaning I'm going to bring my constant to the other side, and I do the inverse operation so that x equals 56. But don't forget, as you're doing all of these, you must have the degree symbol. And I'm going to look for that in your work. This work I have here, you must have this work to get credit. So let's look at our next one. I know 3 angles, and I don't know the last one. But I know that all 4 equal 360. So if I add my constants together, I get 221 plus x equals 360. Do the same process to find out that x equals 139 degrees. We have to put the degree symbol because these are the measures of their angles. So let's look here. It's 55, 143, and 90. Where do I get that 90 from? My brain should automatically know that that square means it's a right angle, meaning it's 90 degrees. So on your paper, you need to write in 90 degrees for that, what I have circled for that little square. I'm going to be looking to see that you have 90 degrees written. When I go solve, I combine my like terms. I subtract my 288 to get x is 72 degrees. Let's take a look at my next one. Same setup. I add all the constants to get 266 plus my missing angle. I subtract 266 so that x is 94 degrees. I want to see these two on your paper. Exact same work, exact same setup. I'm going to be looking for them. If these two are not completed, you will lose 2 points. So let's take a look at number 7. If you've noticed, I've kind of already circled something here. I've circled these 2 angles, the 97 degrees and angle 2. Why did I circle that? And I want you to write in on your paper that these 2 are vertical angles. Vertical angles are the same. Therefore, angle 2 is equal to 97. I've already found one of my angles. Well, after that, I need to see that I've got a quadrilateral with angle 1. I've got a 61, a 97, and a 90. I do the same work I did on my other examples, so angle 1 is 112. But now look at angle 3. Angle 3 here is in a triangle. I know the 2 angles are 97 and 58, so now my brain has to shift. It doesn't equal 360, it equals 180. But the steps are the same. so that the measure of angle 3 is 25. Okay. Number 8's the same. If I come down here, I've got vertical angles. But more important, these three angles here, 15, my unknown, and 104, all add up to 180. What this does for me is when I solve it, that missing angle here is 61. It's vertical to angle 1, therefore, measure of angle 1 is 61. I'm going through this quicker because some of this is review. Okay, let's take a look here. I've got 4 and 53 that form a right angle. Sorry, not a right angle. They form a straight line. A straight line adds up to 180. So the measure of angle 4 is 127. With what I know here, I do have the opportunity to find another angle. I can find angle 2. Angle 2 is corresponding to 104 degrees. Remember, corresponding angles are congruent. Why did I go in this order of solving? Why did I find angle 1, 2, and 4 before I found angle 3? Well, right now, angle 3 has no relationship with anything but the fact that it is in a quadrilateral. Angle 3 has no other way of solving without me first finding 1, 2, and 4. So there I can do my quadrilateral steps. I add all three angles, I subtract, and get 68. So did I go through 7 and 8 quickly? Yes, but you can pause, you can rewind. You need to listen. You need to understand how I found those angles. We've been doing this. The only difference now is I throw in a 4-sided shape versus a 3-sided shape. So we're going to kind of shift gears and we're going to go into the types of quadrilaterals. There are specific types. Just like every single one of you is a Venice Middle student, you have a specific name, okay? So we have to look at these specific types. So a parallelogram, again, it's 4 sides, but it has opposite sides parallel, both pairs. Opposite sides are congruent. That is different than me saying 4 congruent sides. It is just opposite sides. A rhombus, both pairs of opposite sides are parallel. Opposite sides are congruent, and 4 sides are congruent, okay? So then we look at, and that's the only characteristics those have right now. Then I look at my rectangle. It has both pairs of opposite sides parallel to each other. Opposite sides are congruent, and then it has 4 right angles. A square has both pairs of opposite sides parallel. Opposite sides are not only congruent, but all 4 sides are the same. And it has 4 right angles. Then a trapezoid, the only characteristic that stands all the time for a trapezoid is that it has 1 pair, exactly 1 pair of parallel sides, and only 1 pair, okay? That's important to understand. So let's go look at these. Well, most of us might be able to classify these. If you look at the first shape, okay, you have opposite sides congruent, and you have 4 right angles. Okay, so you should know that that first one is a square. Let's go look at number 11. We don't know anything about the angles, and you cannot assume. You cannot assume that they are. So these markings, those 2 black arrows, means that the top and the bottom are parallel. So this is the only characteristic, opposite sides parallel. Therefore, this is a trapezoid. Number 12, if you notice, there are no markings. There's nothing there. So this would just be classified as a quadrilateral. When it has no other characteristics, it's just a quadrilateral. Now 13 could be tricky for some. If you look at your check boxes above, okay, take a look. Both pairs of opposite sides are parallel. And what does that mean? Okay, I'm going to show you. So this side here is parallel to this side here. Okay, so I also want to show you that this side is parallel to this side. Notice there's no markings for right angles, so that means we can throw a square and a rectangle out. So those can't be our options. But my other two options are a parallelogram and a rhombus. Now, in a parallelogram, we said opposite sides congruent, which is the case here. But there's a characteristic that the rhombus has, the parallelogram doesn't. Right? All four sides are congruent. That's what makes this a rhombus. So yes, it is a parallelogram, but it's a special type of parallelogram called a rhombus. So I want you to pause now and try these on your own. All I'm going to do is go through rather quickly and show you the answer, but you need to first try it and see if you were correct. That's how you'll better understand it. Okay, let's look. 14 is a parallelogram. All we know is opposite sides are parallel. 15, we see the four right angles. We see the opposite sides are congruent. It's a rectangle. My bottom one, the only thing that's marking there is opposite sides parallel. I only have one pair of opposite sides congruent, not both. So this is a trapezoid. And then 17, if you take a look at that, it's four sides, but there's no other markings, so it's just a quadrilateral. So this is where we really have to stop and think. We have to decide if it's sometimes, always, or never true. Meaning, could a trapezoid ever be a rectangle? No, because a trapezoid does not always have four right angles. The only characteristic of a trapezoid is opposite sides parallel, not both opposite sides, just one. Is a rhombus a parallelogram? That will always be the case because a rhombus will always have both pairs of opposite sides parallel, both pairs of opposite sides congruent. So that's why it's always a parallelogram. Is a square a rhombus? Yes, a square is always a rhombus, but a rhombus will not always be a square. It will sometimes. So the reverse, the counter of these changes. This is a very big skill that you will see again in geometry. And is a parallelogram a rectangle? Well, that one is sometimes. Because sometimes the parallelogram could be a square. The parallelogram could be a rhombus. So parallelograms are sometimes other things. So how'd it go? This is a lot of vocabulary and a lot of understanding the concept. It is okay to go back and watch again. You all need to start doing that to better understand the concepts.